And warriors, that's how the apple falls. And it's time to just glance through gravitation with me, Shreyas, your physics master teacher at Vedantu. So let's talk about the most important topics which is required for your 12th standard. Some of you have already started the journey in 12th, maybe for JEE, maybe for NEET, and you would have realized that the chapter of electrostatics is very much similar to the chapter of gravitation. Some of you have forgotten it. Some of you think that yes, it's a good time to revise it. Some of you might not even have started your journey. It's okay. It's all for you, the chapter of gravitation. But we'll be doing only those things which are required for electrostatics. Like satellites and Kepler's laws, they're important, but not important for 12th standard electrostatics chapter. So I'll be focusing on those concepts which will help you in your 12th grade electrostatics and Gauss's law chapter. And those of you who do not know me, my name is Shreyas. I'm a physics master teacher. You can definitely get to know more about me on my Instagram. And I love traveling and eating and obviously teaching, and I love physics too. Hello Ankit, hi Pranal, Pujari. Let me sing a Kuti story. Pay attention, listen to me song. Thalapathy Vijay. Is that a song from the movie The Beast? I'm not sure. How to increase the speed in engineering entrance exam? It's all about manipulations. You would have seen people who are very quick, smart, or very to the point. They can think instantly. So it's all about spontaneity, number one. Number two, it's all about the calculation speed, and number three, it's manipulations. How well you can play along with these things is what matters. So Sri Mrithula, this is the session both for JEE as well as NEET, and like I told, I'll be teaching I'll be going through all the concepts which are required for 12th standard electrostatics, be it JEE or be it NEET. Hi Chaitra, hi Kevin, Vanakkam, bonjour, hola, and I hope you have hit the subscribe button. If you have not, please do that now, or else you'll miss the classes. And hit the like button. Obviously, you have to show your love and support. How can we proceed without that? So let's begin. And yes, please join the Telegram channel too. Venkat Raman, hello. Bonjour also means, hello. It's, which language is it? It's French. Okay. So do I know French? Maybe, may not be. Okay, let's start with the gravitation chapter, guys. I hope you guys are ready with the session. Hello, XIC. Welcome, welcome, welcome. Where is my pen? Oh, my pen is here. Okay, let's start with the chapter of gravitation. I'm very good, Gokul Manan. I'm very good, fabulous. I'm all eager to see you in 12th standard. I'm all excited because this is a very, very interesting month. A lot of exams for 10th, 12th, 11th. So many things happening. And I'm all geared up, full of josh, just to work hard for you. Now, see what are the important things in gravitation which you should know for electrostatics and Gauss's law. Number one is the force. Number two is the field. Number three is the potential energy. Number four is the potential. And yes, acceleration due to gravity. If you know all these things, then your journey or transition to electrostatics will become smooth and you will relate many concepts. All right. And Thalapathy, oh, your chemistry paper. Guys, I'll be doing a lot of stuff for physics paper too. Just give me 2-3 days. Your English paper is there, I think, in the next 2-3 days. So immediately after that, we are going full-fledged KVPY and physics marathons for your board exam. Okay, so don't worry, I am there. All right, thank you, Google Manan. Now, starting with the force. So, first of all, Newton's law of gravitation is an experimental law. You cannot prove it. It's an experimental law, and the law says that any two masses will always attract, and any two masses will always, they will never repel like in electrostatics. That's one exception, or that's the, not exception, I would say that's the different thing in electrostatics. In gravitation, you have mass of only one type. In electrostatics, charges are of two types, positive, negative. Here we don't have. Always they will attract, very, very important. And this force can pass through objects or basically medium. Meaning, if these are two masses, they attract each other. This is Pandu, this is Champa. Pandu loves Champa, Champa gets attracted. Champa loves Pandu, Pandu gets attracted. If a villain comes in between also, nobody can stop their love. So their love is immortal. Nobody can stop them from getting attracted to each other. Keep this in mind. Hello Madhuri, love you Vijay. Thank you so much Vacha. It means a lot when you write these things. It means a lot. Thank you so much from the bottom of the heart. Now this force is proportional to product of the masses m1, m2, but it is inversely proportional. It is inversely proportional to the square of the distance between them. Hence, you rewrite this equation like this. F is equal to G, that's the constant, m1, m2 by r square. Keep this in mind. G was not given by Newton. Who gave the value of G? Put it up in the chat box. Let's see how many of you remember it. Who gave the value of G? Was it Newton? Obviously no. The value of G, that's called as the universal constant. That's 6.67 into 10 to the power minus 11 SI units. Okay, who gave it? Who gave the value of G? Let me know in the chat box. Okay, is that clear guys? Now this is very small value like you can see. So you can also say that the force of gravity is very weak for small masses. Small masses. And it's much weaker than electromagnetic force. Electromagnetic force. Now when you have a proton, oh, how it is saying Shreyas sir will give it. Yes, I will give it to you, but I did not find the value. So the value was given by Henry Cavendish. So he performed experiments and he found out the constant of proportionality is 6.67 10 to the power minus 11. His name was Henry Cavendish. What are the topics to do first for NEET? Same as JEE. I mean, it depends, Shasha, which standard you are in. Are you in 10th moving 11th or 11th moving 12th? You need to tell me that. Or you are in 12th going to write the exam. Please tell me that, or else I might give you some wrong advice. Okay. You will see that in the chapter of electromagnetism, electron protons will attract. There you will never worry about the masses of electron and proton, creating gravitational force. Because when the masses are small, it's going to hardly matter. Electromagnetic force will dominate over the gravitational force. These are the pointers which you should keep in mind. Okay. So next point that you should know is the principle of superposition. Superposition, meaning imagine a student who listens to his parents, who listens to his teachers, a student who listens to his friends, a student who also listens to what is written in the books, a student who also listens to what the teacher says in YouTube. Wow, what a student, right? He does everything. Mom says wash the dishes, he washes. His friend says come to party, he comes. His teacher says do the homework, he does. His YouTube teacher says that do this, whatever I'm telling you, do these chapters, do it in this order, attend my classes, do this, he does that also. My God, what a talented guy. So, same way of mass which is in presence of other masses will get attracted by every other mass, and it will the force of interaction between two masses is not influenced by the presence of a third mass. It will not think, oh, teacher told me that, but now when mom and dad come, suddenly your behavior changes. That behavior does not change because somebody else is present. If these two masses have a force of F and F, these two masses independently have a force of some other F and some other F, then this F will not be affected by this F, and this force will not be affected by the other force. It's independent. So what happens is basically, you will see any mass gets, has that interaction independent of the other masses. That's the superposition principle. So I can say that the net force on any mass is as if all, is as if all masses pull independently of each other. Hence that net force will be F1 plus F2 and so on and so forth. How many ever forces are there? So this is the net force on any mass, but this is vector, so you should put a bar over here. It means you have to do vector addition, of course. So this mass being pulled by many forces, you take the vector sum, and you will see vector sum comes many times while solving problems. Let's solve some questions based on the forces. Here is the first question coming up on your screen right now. 3 equal masses m are placed at the 3 vertices of an equilateral triangle of side length 2a. The gravitational force exerted by this system on another particle of mass m at the midpoint of a side is given by which of the following? The next lesson in Zero to Superhero, it's going to take some time, bacha, because I'm going to wait for the physics paper to be over. Before that, I'm not conducting any Zero to Superhero sessions. I'll be doing session for the Manipal entrance test. I'll be doing sessions for the board exams. I'll be doing sessions for KVPY. Till these exams are over, no Zero to Superhero. But after that, 11th standard and 12th standard term 1 syllabus like current, electricity, all of that, electrostatics, all these chapters are going to be taught to you in Zero to Superhero. Okay, so let's do this question, guys. First of all, these masses are placed on the vertices of an equilateral triangle. So I think the first step should be to draw that equilateral triangle and to show those masses, the 3 masses which are being placed over here. 3 masses are having the value m, this is also m, this is also m, and the side length is basically 2a. This is also given to you. Now there is another mass, which is placed at the midpoint of a side. So let's say I take this side and this is the midpoint. So this is our mass which is placed over here. The question is, what is the force acting on this mass because of the other masses? Use superposition principle, meaning this mass will be pulled by this, this and this independently. So what I will say is that the forces acting on this mass are this force, of course, but wait a minute, this mass and this mass will apply the same force, isn't it? Shouldn't this force over here be same force in magnitude as that of this force? Think about it. Hence, what does it say? It will therefore cancel each other. This force and this force, opposite, equal, masses are same, distance are same, midpoint of course, so they will cancel. The only force which will remain then, is then the force by this mass, and this is the total force. Hence, the net force is just F. The blue lines, the blue arrow marks are going to not matter because they are going to cancel. For that, I think I need the distance between these two. So I think I need the height of the triangle. So the height of the triangle is the hypotenuse, which is 2a, into this angle is 60 degrees. So it's opposite the 60 degrees, hence sine 60, which is nothing but 20, sorry, not 20, this is 2a, but guys, sorry, I read this as 20 by mistake, my bad, it's 2a. So it will be nothing but 2a into root 3 by 2, so which is nothing but a root 3. That's all. Now take this value and find the value of f. F will be g m into m by that height square. So it will be g m square by a root 3 whole square. So this will be g m square by 3a square. That's it. That's the answer. And is it there somewhere? Just check this out. Yes, it is option C. Can you see that 3? No, it's not D, guys. Root 3 is not the correct answer. Hello, Madhesh. Nice you came, bacha. Okay. And my physics knowledge not that much sufficient. I want guidance for physics from you to crack JEE NEET. Sorry, NEET. My biology is strong. Chemistry is manageable. Chaitra S. Definitely, bacha. Can you wait till the end of the session? I'll definitely give you guidance for sure. Just wait and put the same comment, copy paste it towards the end. I'll definitely read your chat and I'll answer you. Okay. Is the nurture series enough content for the concepts of JEE Mains level? Yes, more than enough, Venkatraman Krishnapuram. More than enough. Okay, you need it. And do it along with your regular V Pro classes. That is like excellent combination. Trust me on that. Okay, let's move on to the next question, guys, coming up on your screen. Yes, Chaitra, I will help you. Just come towards the end again. I'll help you out. Hello, Heron Prajapati. Welcome, bacha. An infinite number of particles, each of mass 1 kg, are placed on the x-axis at 1, 3, 9, etc. Magnitude of the resultant gravitational force on 1 kg mass kept at the origin is. Let's draw it, only then I think we can solve this question. So first of all, let's draw this situation. So infinite number of masses, the magnitude of the resultant on 1 kg mass. So this is my 1 kg mass which is placed over here, and then this is your x-axis of course, okay, and then you have other masses. So more 1 kg masses, but they are placed at different distances. Like you can see, one mass is placed at a distance of 1 meter, then next mass is placed at a distance of 3 meter, then the next mass is placed at a distance of 9 meter, and so on and so forth. This continues. So the question is, what is the resultant force on this 1 kg mass? So on this 1 kg mass, each mass will apply some force. So the net force will be force by all the masses, F1 plus force of the mass kept at 3 meters plus force of the mass kept at 9 meters plus force of the mass kept at 27 meters, and so on and so forth. Let's see how will the individual terms look like. I have a feeling it will be a series, and we can solve it using some summation formula which you would have learned maybe in series. I'm so sorry. Hari Om. I'm so used to now English names. I'm so sorry. It's Hari Om. Hari Om Prajapati. Welcome, bacha. Alright, so what do we have over here? So we have G, MM. MM is nothing but 1 into 1. So it will be nothing but 1 multiplied by 1 divided by distance is 1 square plus G into 1 divided by 3 square plus G into 1 divided by 9 square, and so on and so forth. I think G is common, and what I can see from here is it's 1 by 1 plus 1 by 3 square plus 1 by 9 itself is 3 square. Square of that will be 3 raised to 4. Next term is nothing but 27. 27 is 3 cube. 27 is 3 cube. Square of that, so that will be 3 raised to 6, and so on and so forth. This will continue till infinity. Everybody got it? Everybody got it? Yes, Rohit S. The force between two charges is also independent of the third charge. The principle of superposition is also valid for charges, magnetism, everything, bacha. Very good. Yes, I'll be taking sample paper. I've already solved the sample paper long time back, but I'll be doing mock questions, short questions, formula revision, concept revision, most expected questions, all of this for term 2 physics. It's a promise, but I'll be doing it after your English paper, language paper. Okay, keep this in mind. Alright, now don't you see this is nothing but a GP, decreasing GP, where the first term is this one, this is your ratio, common ratio. So you know in a GP the first term is A, here it is 1 by 1, and the common ratio is nothing but 1 by 3 square, and the sum till infinity, remember, is A upon 1 minus R for a GP. This is for a geometric progression series. So now just use the formula over here. A is nothing but 1 upon 1 minus common ratio. Common ratio is 1 by 3 square, because ratio means this term to this term, what you need to multiply to get it. 1 by 3 square into 1 by 3 square is 3 raised to 4. 3 raised to 4, 1 by 3 raised to 4 into 1 by 3 square is 1 by 3 raised to 6. 1 by 3 raised to 6 into 1 by 3 raised to 2 is going to give you 1 by 3 raised to 8. So the common ratio is 1 by 3 square. So this will be nothing but G into 1 by 1 minus 1 by 9, which is nothing but G into 1 by 8 by 9. Hence that 9 goes on the top, 8 comes below. So the answer will be 9G by 8. Is that clear? Do we have it? Yes, we have it as option A. Option A. Very good. Oh yes, Brawl, with KS, V is equal to IR mein voltage is proportional to current, but P is equal to IV mein current is inversely proportional. So please solve my doubt. It depends on what you are keeping as constant, what kind of circuit it is. So it's not, see, if power is kept constant, then yes, voltage is inversely proportional. If resistance is kept constant, then voltage is proportional to current. So it depends on what is kept constant. If it's a series circuit and current is constant, right? Current only is constant. battery if it is constant. If your input power is constant, then voltage is inversely proportional. So it depends on what is kept constant. Your 12th lectures, Hari Om Prajapati, let me tell you, I'll be doing problem solving sessions right from maybe next week or something, or this coming week basically, whatever the next week. So you will not have full-fledged classes, like lecture 1, 2, 3, 4, 5, 6, 7, 8, because those have been already done in the Pathfinder series. So the detailed classes are already over. So I'll be doing problem solving, PYQs, advanced level problem solving, one shots, revision, recap, don't do this for every chapter. That's what we'll be doing. Okay, so is it not true that V is always proportional to I? Brawl? Yes, it's not true. It depends on what is kept constant. Yes, it depends on what is kept constant. But we say, Ohm's law says that voltage is proportional to current for a given conductor. Read the complete Ohm's law statement. For a given conductor, the voltage is proportional to the current. That means resistance is kept constant. I hope this is clear. Okay, so moving on to the next question coming up on your screen. Yes, one shots will be also there, Sama Irana, definitely. Wow, very good, Rohit. Congratulations. I'm pretty sure you like the smell of the new books and it's fabulous. This time Sattva, more improved, different design, and also questions are also better arranged. Let's have a look at this question. You are given a total mass of 10 kg. So you have a lump of 10 kg mass. You have to split it into two. Divide it into two parts so that the force between them gives the, for a given distance is maximum. Now force between two masses is G m1 m2 by r square. Now in this question, according to this, the force has to be maximum. G is constant. R is also a constant because given distance. That means for force to be maximum, it clearly states, it's clearly implied that the product should be maximum. The product of the masses should be maximum. Now if you split 10 kg, multiple options are there. Try it out. It's very obvious. I can split it as 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5 and 5. Now if you do 6 and 4, it's again a repetition. Whether you do 4, 6 or 6, 4, it's one and the same thing. So no point going here. You will see the product will be 9, the product will be 16, the product will be 21, the product will be 24, product will be 25. This is the max value. So the masses should be distributed equally. In fact, it's always true that if the sum of two numbers is constant, I'll write it down over here. If the sum of two numbers is constant, then their product is maximum when they are equal. Keep this concept, this property in mind. It's very, very important. Yes, if you're in 10th class, just move to 2022, 2023 Brawl with KS. Very good. You will be thrilled to know that we'll be doing classes for 11th standard also. So make sure after your board exams are over, stay tuned on the channel, and also in the next 2 days, more sessions for physics, science, term 2 exam. So this property helps you understand that since their sum is constant, their product is maximum when the two numbers are equal. Very important property, not just for this problem, but for many other questions as well. Keep this in mind. Yes, 5 and 5 kg, like you can see right over here. Alright, so what do we have? Two bodies of mass m and 5m, radius r and 2r respectively are released in free space with some separation. If they attract each other due to force of gravitation, what is the distance covered by the smaller mass before they collide? Now these kind of questions can also come in electrostatics, where two spheres are charged and they collide. Where do they collide? How much do they move? And so on and so forth. Let's draw the diagrams first. This is the diagram before, and then I'll show the diagram afterwards. Two bodies, mass m, 5m, radius r, 2r. So this is radius r, this is r, having mass of m. And you have another mass over here, and this radius is 2r, and the mass is 5 times of m. Okay, so this is how it looks like. Their centers are separated by a distance of 12r. So center to center distance is basically 12r. Now, what happens? They are released because of their force of gravitation, mutual gravitational force. They attract and they collide. So eventually, this is like afterwards, they will collide and it will look probably something like this. Now, in this process, when they collide, there is one thing which does not change, and that is what should click in this question. It's not directly mentioned, but you should understand it. What is that thing which does not change? Come on, my warriors. I don't know, Sri Sam. We'll see. Have a look. I'm going to solve the question, obviously now. Okay. So what is that one thing which does not change? That one thing which does not change is the center of mass. The center of mass of this entire system does not move. The center of mass is at rest because a gravitational force is an internal force. Keep this in mind. Because it is an internal force, there is nothing from outside to move it. So center of mass stays there as it is. Now, what you should also realize is that if this smaller mass moves certain distance, like you can see from here till here, like I'm showing this line. Okay, see this and maybe see this. So this mass has basically moved this much, let's say x1, and this one over here has also moved something. Let's have a look at it. How much has it moved? All right, it has moved this much. This is x2. Both this mass and this mass have moved, x1 and x2, and there is an obvious relationship between them. If you notice, since center of mass is at rest, I can very well say, since center of mass is at rest, the mass into displacement is constant. m1 x1 is m2 x2. This is a standard property you should know from center of mass chapter from 11th standard. If you don't know it, then gone. So the mass is m. So m into displacement is x1 will be equal to the other mass, which is 5m into x2. Therefore, x1 is equal to 5 times of x2. This is one equation. Everybody got it? m1 x1 will be 5m x2. So x1 is 5 times of x2. Another thing which you will notice is that this distance x1 plus x2 is something. What will be x1 plus x2? Just see this geometry, you will understand. This length is this length minus this. So this blue length is this total length center to center minus 2r minus r. So it will be nothing but 12r minus 2r. Do you understand? This much is r, this much is 2r. This total center to center was 12r. So subtract the 2 radius from 12r. So this will be nothing but 9r. And x1 is 5x2, but I don't want x2, I want x1. So this will be, x2 will be x1 by 5. So this will be nothing but 6x1 by 5 is 9 times of r. So this goes 3 times. So therefore x1 will be 3 5s are 15 r by 2. x1 is the displacement by the smaller body x1. So hence 15 r by 2 means 7.5 r. That's the answer. Hi Ranjit. Hi Pawan. Okay. I hope this is clear. Okay. Is that understood, guys? Is that understood? So a lot of concepts from 11th standard are also needed in your 12th grade. So you need to brush up those concepts. If you have forgotten center of mass, now you would have seen how it is important, how it can suddenly come in electrostatics and so many other chapters. How, suddenly you might need geometry. How suddenly you might need some topic which you would have studied before, Newton's laws, anything. Perfect. Let's move to gravitational field. Yeah. And I hope, guys, you have smashed the like button in case you have joined in late. And if you have not yet subscribed, please subscribe to the channel as well. And yes, please be regular because this is a very important series. Already have done basic maths for your 12th, vectors for your 12th revision so that you are up to date for the forthcoming chapters. Okay. Now, gravitational field. What is the meaning of gravitational field? Every mass around it creates a field meaning it makes its presence felt to other masses, like Earth and the Moon. How does the Moon know Earth is there? There is some field which the Earth creates, which has information of how heavy Earth is, how far the Earth is, and that field helps Moon decide how much force it should experience. Even the Moon creates a field around it, and it also applies a force on the Earth. So every mass has its own influence, makes its presence felt on other masses, and that presence, that influence is called as the field. In fact, the field is defined as the force acting per unit test mass due to the other mass whose field you are calculating. This is the mass creating the field. This small m is basically your test mass. You are testing the field. Okay, this is you are testing the field at this point. So you are finding the field at this particular point. So the field at that point is nothing but the force acting per unit mass. It's a vector quantity, so you will put the bar. So what's the direction of the field? Simply put, it's the same as the direction of the force acting on it. So say for example, if I have this mass m over here, if I have this mass m over here, if I put a test mass, the test mass will experience a force this way. So the field is also this way. If I put a test mass here, the field will be still this way because the force will be this way. If I put a test mass here, the force will be this way. Test mass here, 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 force will be this way. Here, this way. Here, this way. Here, this way. Here, this way. So you can see it is attractive field. This is called as an attractive field. And those of you who have already studied electrostatics know this. This is the field diagram for a negative charge. Negative charge has an attractive field. Positive charge has a repulsive field. That's what you can see. Term to revision after your English and language paper. Definitely. Yes, it's almost electrostatics. Definitely hurry home. Correcto. So this is your field diagram. And when you continue drawing these lines, when these lines, when you extend it, you will see that these are called your field lines. These are your field lines created by gravity. Each mass creates a gravitational field. You can also go the other way around. For example, if there is a gravitational field, let's say E, and you place a mass at this point, then this mass will for sure experience a force along the tangent. It will definitely experience a force along the tangent. That force will be the mass times the field. Keep this in mind. You just move the mass here, mass into field is the force. It works both ways. You can calculate field or you can also calculate the force acting on a mass. This is the force on a mass kept in a field. Do you remember electrostatics? In electrostatics also similar formula is there. Force on a charge in some external field is the charge into the field. That's the only difference. Yes, daily classes. This time my classes will be there, Pawan KSS. You will see my daily classes. If not at 7, 5:30 at least. And sometimes there could be some changes for some unavoidable reasons. So make sure you join the Telegram channel. Keep a tap on the community post and hit the subscribe button so that you see when the upcoming classes are. Okay, all these are important properties, my warriors. Next important thing is gravitational field at a point due to many masses. Imagine this, that I tell you that there is a mass over here, there is a point over here, and there are multiple masses, m1, maybe I call this m1, maybe I call this m2, maybe I call this as m3. Okay, these are multiple masses, and I want to know at this point what is the field due to all of them. Whenever such a question comes, remember, number one, field is vector. So you need to be very careful about the directions. Number one. Number two, this point, okay, this point will experience field in multiple directions. Number one, it will be here. Number one, it will be here due to this mass. Remember, each mass creates attractive field. So field due to mass 1 will be here. Field due to mass 2, so this was along this line. Then along this line, you will have another field, something like this. And due to this mass also, you will have another field like this. This will be nothing but E3. Now, adding them vectorially, you will get the net field. It will be E1 bar plus E2 bar plus E3 bar. This is again superposition. Superposition. Keep this in mind. So this is your net gravitational field. It is always attractive. Okay. So for a JEE 2022 aspirants, go with one shots and only go with Pathfinder or Nurture when you face a specific difficulty in a specific subtopic. You need detailed explanation. Only for that subtopic, you go for the detailed class. Okay. So which is the highest weighted chapters for NEET? You can ask me, Ria, probably towards the end. Definitely, I'll help you out. Okay. Great. But you will see that mainly mechanics has to be done, Ria, right from the scratch. From basic maths, vectors, kinematics, till gravitation, that includes SHM and rotation, Ria, that should be 110% done. There is no doubt about it. That is like bare minimum you should do. So be strong in mechanics, everything else follows. Even if you have not done fluids, thermo, it's okay. But do the mechanics part. And once this is done, give second priority to waves. Okay, that's the thing which I can tell you. Now, gravitational field due to a ring, these are standard formulas which you should know. In fact, I had explained this problem during the vectors revision class just few days back. If you have not watched the vectors revision class which I have conducted, please watch it. It's there in the playlist or past videos. So if there is a ring over here, this point will experience field. So all the masses over here will apply forces like this, like this, like this, like this, like this. Okay, and you will see that there will be a net force which will be created, which will be in this direction, or a net field which will be created in this direction. And this net field is given by A is the radius of the ring, R is the distance from the center. Let's say M is the mass of the ring. It will be given by G M divided by, here you will have A square, radius square, plus the distance square, whole raised to 3 by 2, and here you will have R. This is the formula for the field, something which you should remember. Standard formula. This comes from the vector addition of the fields due to all small masses on the ring. All the small masses on the ring. This mass, this mass, this mass, this mass, this mass, this mass, this mass. All the masses apply fields, and the resultant vector is given by this formula. It is always along the axis of the ring. Keep this in mind. Next important formula which you should know is for a shell. Hello Sneha Patel. Hi Ritesh. All right. So what do we have for a shell? Shell means hollow, thin sphere. It's empty. It's completely empty inside. Keep this in mind. Keep this in mind. I'm very good, Ria. I hope you guys are doing great. And thank you for putting up, Ria and Sneha, the warrior, Ninja Warrior logo display picture. It means a lot. It makes you guys easily noticeable. This is radius R. This is the mass of the shell. It's empty inside. There are two cases which you should know for a shell. If you have forgotten, I'll remind you. The first case is when you are inside. The first case is when you are inside, and the second case is basically when you are outside. So this is when you are more than R, that means you are outside basically, and this is when you are inside the shell. So the two formulas are as follows. The electric field when you are inside is just given by 0. It cancels. It's 0. No matter where you are, where you are, it will be 0. Thank you, Uma. Oh my God, simulating tech, is it? Even I don't know my name is there. Oh, I'll have a look maybe. I have not received the new book, by the way. So the field will be 0 everywhere inside. It basically cancels. Keep this in mind. It cancels. But when you are outside, then the field is just given by Gm by r square. This is as if it is a point mass. If you remember, the point mass, if there is a point mass m and you are at a distance r, the field value at this point is Gm by the distance square. There is no mm. Mm is there only in force. For field, one of the mass goes away. So it is as if the entire mass is at the center. Oh my God, can I just do undo? Is it there? Oh, I don't know. I think I lost it. Anyways, I'll just put it over here once more. No problems. So you have this over here and this is your radius. This is your radius. Okay. So I hope this is clear, guys. Very, very important. Cool. Shall we move ahead? So when you're outside, the shell behaves like a point. When you are inside, the field cancels. Hence, the net field is 0. Very important property of a shell. And for a point mass is Gm by r square. If you have studied electrostatics, you know similar formulas are there. Electric field is kq by r square. Electric field is kq by r square. Instead of G, you have K. Instead of mass, you have charge. That's all. That's why we are revising this. It's important for your electrostatics 12th standard NEET and JEE, guys. So very important class. You cannot ignore gravitation, because if you study electro, you study gravity. If you study gravity, you study a lot significant chunk of electro as well. Okay, so moving on to the next one. Gravitational field due to a solid sphere. This is solid sphere. It's completely filled. Okay, it's a huge chunk of mass. Now, again, there is a small modification in this formula. This is R. The mass of the solid sphere is m. Let's talk about when you are outside and then inside, just like we took two cases. So first, let's go outside. So let's say I am outside. So R is more than R and I'm outside. Then the field is just given by, again, Gm by r square. It's as if a point mass at the center. So when you're outside, what matters is the distance from the center to where you are. That's all. So it behaves, all the mass concentrated at the center. That's how it behaves. But when you are inside, right over here, R is basically less than R, and you are inside, then the field is slightly different. It is not zero. The field due to all the masses inside this part have an effect. You can visualize there is a small sphere which is formed over here. This much chunk of mass will still attract you. Okay, and that formula is given by G m r divided by r cube. This is the formula. So the chunk of the mass which is inside attracts you. You will notice in electrostatics, you would have seen one formula, or you will see a formula for a charged, uniformly charged, non-conducting solid sphere. So in that case, the formula is G ke badle you will have K into charge by r cube into small r. Small r is the distance. Okay. For 12th, Shweta, if you remember most of these things, then no need. Concentrate more on 12th. But for revision, if you find the need, please watch it. Otherwise, there is no need, Shweta. Okay. Now, Earth is a solid sphere. So, you can take the Earth as a solid sphere, and the calculations of the field will be very much similar, whether you are outside or inside, to that of a solid sphere right over here. So you don't need anything more, anything less. Is that clear, guys? So let's start solving some questions based on the field formulas. First, The intensity of the field, meaning the field itself, inside the hollow spherical shell is 0, minimum, variable, maximum. Come on, this is an easy one. I want all the answers to be spammed in the chat box right away. Come on guys, start spamming. Okay, Uma saying A, Hari Prasad saying 0. I just showed it to you. When you are inside, it cancels, it is 0 for a shell. Hence the correct answer is 0. Very good. Perfecto. Proud of you, Pavan, Shweta. Draw and draw, Hari Prasad. Very good, Uma. Excellent day. Amazing go, guys. Moving on. Next question. Wow. What is this? This is a previous year question, I think. I don't remember the year, but for sure, I think this is a previous year question. Let's solve this. The field due to the leftover part meaning this part. This is the leftover part. Okay. From which a part has been removed out. You can see this part has been removed out. At a point which is very, very far away, would be nearly, approximately. Let's try and solve this. I think we should first find how much mass is remaining. For that, I should know how much mass has been removed. How much mass has been removed. So the mass removed can be found by the density into the volume removed. Now what is the density? The density of the sphere. Look at this. The gravitational field at this point. M is the initial mass, I believe. M is the mass of the complete sphere is M. So total mass is M. Total volume is 4 by 3 pi r cube into volume which is removed. For that, I think you need this radius and diameter is r, so radius will be r by 2. Radius will be r by 2. Hence, the volume which is removed will be 4 by 3 pi r by 2 whole cube. 4 by 3 pi cancels. R cube also cancels. I will be just left with m by 2 cube, which is just m by 8. So m by 8 is removed. So hence, I would say the mass remaining small m will be m minus m by 8, which is 7m by 8. That's what I got till here. Everybody fine? Give me a thumbs up if you guys have got it. Alright. So mass removed has been found by density into volume removed. Volume has been calculated by the radius. So since diameter is r, this is r by 2. You can see easy math. A lot of things cancel. You get m by 8 is removed. So remaining will be 7m by 8. Now what is the next point? This is very important line. Very far away point. When you are very, very far away, think how will it look like? Just imagine that diagram. Just imagine this. It will look something like this. One small hole. And this is there. This is the part which is remaining. And you are very, 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 very far away at this point. How does it look like? This part which is shaded is here. Does it look almost like a point mass? Does it look almost like a point mass nearly? So does this radius even matter now? No, right? You'll assume it like a point mass which is at a distance x. That's it. So you know how to find the field. So the field will be that of a point mass, which is g, mass which is remaining, divided by the distance square. The mass which is remaining is 7m by 8, and the distance, that's just x. So x square. That's it. That's the answer. And do we have an option like that? Yep, do we have? Yes. Option C, of course. 7 by 8 gm by x square. That's it. Done, done, done. It looks scary just because you hear the word PYQ, but this approximation is very important because it is a very far away point. Hence, the mass can be assumed like a point mass. And that's why the problem becomes very easy peasy lemon squeezy. Else it would be very difficult. You have to find the force because of the entire mass. You have to find the force or the field because of the mass which has been removed. Then you have to subtract them. Crazy. It would be little bit tricky to solve. But that's what they do. You have to make use of the hidden information in the question. That's what PYQs is all about. Okay, this one is easy peasy, lemon squeezy. You should know how to draw the graphs. The gravitational field due to a solid sphere varies with distance from the center as. Come on guys, this one is simple. If you have forgotten the formula, I'm just writing it over here. The field will be Gm by r cube into r when r is less than r, and when r is more than r, then you have the field given by Gm by just r square. Come on, this is simple. Shweta, are you scared of cockroach, or are you scared of falling off the bike, or are you scared of water? What you should do? You should learn swimming. If you are scared of cockroach, you should realize, even if the cockroach flies, it's okay. It can't hurt me. Yes, you should be scared of tiger. You can be scared of snake, but no point being scared of, I don't know, a grasshopper. You just want to stay there, or a frog. No point being scared of water unless, you are being forcefully drowned. If you just fall in water, you can swim. No point being scared of a bike, because if you know how to balance, you will very well handle it. Same way, no point being scared of a numerical. Numericals will never eat you. They will never threaten your life. It's just that you have to practice, solve them, think, try via different methods, manipulate, and try to solve it as much as possible on your own. That's it. You will pass through it. There is nothing to be scared of. Trust me. Okay? It's too early. Okay. So, do last 45 days strategy? Yes, Surya, I'll definitely do it. Option B? Yes, it is option B. You can see it's a straight line, bacha. It's a straight line. This is proportional, and here it is inversely proportional. You can see that. Here it is proportional to R. Here it is inversely proportional to R square. That's it. Done. You can see it right over here. Very good. Excelente. Amazing. Moving on to the next one. Now, acceleration due to gravity. This is also a very important topic, especially if you talk about JEE as well as NEET. A lot of questions come from finding the gravity, acceleration due to gravity at some height or at some depth, or changing the planet sizes. So, look at this. First of all, experiment. You would have heard about this. You would have seen some videos, or you would have seen some simulations. The main thing about acceleration due to gravity is that it is not dependent on the mass which is dropped. It only depends on two things. What are the two things, my warriors? The acceleration due to gravity depends on only two things, assuming no air resistance, of course. It does not depend on the mass which is dropped. Even a feather and a stone come down at the same time. It depends on the mass of the planet. It depends on the mass of the planet, and also where you are on that planet, meaning the height or the depth, the radius, basically the geometry. That's all. So the mass of the planet, not the mass which is dropped, mass of the planet itself, and where you are on that planet. So on the surface of a planet, you should know this formula. If the surface of the planet, if you're standing, the acceleration due to gravity generally has the symbol G0. 0 stands for no height, no depth. R is the radius. M is the mass of the earth. The formula is given by Gm by R square. Okay. So this is the formula which you get on the surface of the planet. Very, very crucial. Sometimes this is also used for substitution, where you just write Gm as G0 R square. Okay. Sometimes you can do this substitution and transform that equation very easily. Moving on to the next one. At some height h, when you are at some height h, then the formula modifies to this. So gravity, acceleration due to gravity at height h is Gm. Instead of R, it is R plus h. So the total distance, that's all the changes. So it is R plus h whole square. Very important formula. But there is also an approximate formula. How many of you remember that approximate formula? When h is much smaller than r, then you will use this formula. gh is equal to g naught, acceleration due to gravity on the surface, into 1 minus 2h by r. Only then you will use this. Okay, not every time. So typically the radius is 6,400 kilometers. So if the height is 100, 200, 400 kilometers, only then use this. Otherwise, if it is 1000 kilometers, 700, 800 kilometers, then use this formula. So it will be clearly mentioned, or it will be understood from the given data whether to use this or this. You will never be confused. You have to just read the question carefully, see the values carefully, understand whether it is small or big value. That's it. You will never fail to apply it. Then you have acceleration due to gravity at some depth d. The formula of acceleration due to gravity at some depth d is given by gm by r cube into r minus d. If you notice, this is very similar to the solid spheres field formula. Where is that gone? Solid spheres field. Here it is. Yes, solid spheres field. Gm by r cube into r. R is the distance from the center to that point. So notice this over here as well. R minus d is just this. This is nothing but r minus d, which is, I think, small r. So it's exactly similar, one way of remembering this, or you can also remember this as g naught into 1 minus d by r. Now, either you remember this or you remember this, it's fine. Mainly students get confused between this formula and this formula. It looks similar, g naught 1 minus 2h by r. Here it is g naught 1 minus d by r. The 2 is not there here, notice, for depth. For height, that 2 is there. Have you understood? Have you understood? Is this like a one shot? Yes, Kalyani, this is like a one shot revision of gravitation needed for electrostatics. I am not teaching complete gravitation like satellites and Kepler's laws, not needed for electrostatics. So I'm not doing that. But potential energy, field, force, all these things are important. I hope this is clear. Understood, guys? So keep a note of all these things. What is there, what is not there. Let's start solving some questions. At what altitude will the acceleration due to gravity be 25% of that of the Earth's surface? Let's do this, guys. At what altitude will the acceleration due to gravity be 25% of that of the Earth's surface? Now, what is the given information? It says GH is, gravity at height h is 25% of G naught. It means GH, 25% means 1/4. GH is G naught by 4. Now, do I know the formula for GH? Of course. But will you use this formula, the first one, the top one, or the bottom one? Let me know. Oh yeah, it looks like that. Yeah, because I'm covering everything of field, force, potential energy in detail over here. So which formula will you use? Will you use the upper one, the top one, or the bottom one? Let's see. Hari Prasad saying option C. I don't know. Let's figure it out. You should know which formula to use. See guys, gravity has changed by, where is that? 25%. It has come down. It's a lot of change. That change only happens when the height is lot or too much. So you cannot use the approximate formula. This is not allowed. You have to use this. So let's stick with that formula. So it will be nothing but Gm by r plus h whole square, and G naught is Gm by r square standard, and this 1/4 remains. Gm goes, so 1 by r plus h whole square is 1/4 r square, taking roots on both sides. 1 by r plus h is 1/2 r. Flipping it, r plus h is equal to 2r. Taking r on the other side, h will be equal to r. That's it. So is it there somewhere? Oh, it's not C, bacha, it's option B. It is option B. Yep. So If you have used the bottom formula, then you will get some wrong answer. Do not use this, because height is not small, height is large. In fact, if you notice, the height has come out to be radius. It is not smaller. So be very careful. That's why I'm doing all these questions. Moving on to the next one. Mass of the moon is 1/81th of the earth, but gravitational pull is 1/6th of the earth. Ratio of the radii for the earth of moon. No, it's not earth of moon. It should be earth to moon is how much? Let's solve the question and let's see what and all is given in the question first. Mass of the moon is 1/81th. So mass of moon upon mass of the earth is 1/81. That is given. Pull is 1/6th of earth, means acceleration due to gravity is 1/6th. So acceleration due to gravity on the moon upon acceleration due to gravity on the earth is 1/6th. Ratio of the radii. So ratio of the radii of earth and moon is how much? This is the question. Read it carefully. You will understand this is what it means numerically. Let's start solving it first. So I think we should use the formula for acceleration due to gravity. So acceleration due to gravity is given by gm by r square. Therefore, gm by g earth, g will get cancelled. Mass is in the numerator, so mass of moon upon mass of earth, and here radius of earth and radius of moon, but it will be whole squared. But I think we need this. You can see it right over here. So bring this guy over here, bring this guy over there. So it will be okay, I'll just keep it over here. Re by Rm whole square will be, take the masses on this side. So it will be Gm by Ge into mass of the earth by mass of the moon. Now this moon upon earth is 1/81. So this is 1/81 of course, into earth by moons. This, just hold on guys, I'll write it in order so that you guys don't get confused. All right, let me just write over here. Mass of earth upon mass of moon. Earth by moon, so it will be nothing but 81/1. Earth by moon will be 81/1. Moon by earth for gravity, will be 1/6. So that's what it is. So Re by Rm will be root of this. So it will be root of 81/6, which is 9 by root of 6. That should be the answer. Do I have it somewhere? Oh yes, I have it. Option B, of course. Yes. Is that clear, my warriors? Got it? Understood? Clear? Can we move ahead? Yeah. So what was needed? You need to know what is given in the ratio, what is asked in the ratio. Need to know the acceleration due to gravity formula. Just divide it. Many things like G got cancelled, and it's just manipulating this algebraic equation. Yo, let's move on to the next one. Wow, what is this? What is this? Crazy. Suppose acceleration due to gravity on the Earth's surface is 10, example, and on the surface of Mars is 4. Mars is smaller, so 4. There is a 60 kg Pandu who moves from Earth to Mars in a spaceship with a constant speed. Neglect other objects like Jupiter, Sun, etc., moons. Which figure best represents the weight or the net gravitational pull as a function of time? So just imagine there is Earth over here. This is your Earth, and there is Mars. Mars is a red planet. All right, and there is this Pandu over here in a spaceship. Just imagine it. He slowly travels from here to here. So the question is, how will the gravitational pull change from the Earth to the Mars? Which graph is the best representation of this? Very simple, logical question. If you get it, you get it. Come on, think carefully. Is it A? Is it B? Is it C? Is it D? He is moving with constant speed. Think about it. Very easy peasy lemon squeezy question. B. Okay. Think carefully. I'll tell you what. When you are near the Earth, Earth's influence will be higher. Earth's influence will be higher. When you are near the moon, Mars, then the Mars's influence will be higher, Earth's will be negligible. There will be some point in between, okay, there will be some point in between where the Earth's influence and the Mars's influence will cancel and the net will be just 0. It will be somewhere close to the Mars. So Earth and Mars's force will cancel at some point. So it should become 0 and it will be only at one point. This will be that point where the forces cancel. It will not be 2 points. Obviously it can't be 2 points. It will be only 1 point where the force cancels. And when you are closer to the Earth, it will be 600 Newton. And when you are closer to the Mars, then it will be 400 Newton. This is actually 400 Newton because acceleration due to gravity is 4 meters per second square on Mars. So it will be 400 Newton. 60 into, sorry, what is it? What is the mass given? 60, yeah. Oh, sorry, it will be, my bad, 6 into 4, 240 Newton, not 400 Newton, my bad. It will be 240 Newton. It's 60 kg, 60 kg into 4, 6 4s are 24, so it will be 240 Newton. So that's why the graph will look something like this. Understood? Hi, Mr. Innovative. Is that understood why it will become 0 exactly once where the force cancels? When you are near the Earth, it will be mg. When you are on the moon or on the Mars, then it will be m into acceleration due to gravity of the Mars. That's why it should be option C. Let's see. Yes, we just saw that it is C. Excellente. Yes, Shweta, it is C. Very good. Very good. Moving on to the next question. Oh, we have already come to gravitational potential energy and potential. So let's see the last part of today's class. This is very crucial for electrostatics. You will see in electrostatics and magnetism, you will have, lot of questions on potential energy, work done, change in potential, potential difference, all these kinds of things. So you need to understand what is potential energy and relate it with the same formulas. It's very, very identical. First of all, when you have two masses, M1 and M2, they have a potential energy between them. So if this is R, the potential energy of that system is given by U. The formula is G M1 M2 by R. Keep this in mind. This is the potential energy of two masses separated by some distance. They have some ability to do work. If you leave them, they start moving. So they have ability to perform work. Keep this in mind. Mr. Innovative, that 0 to superhero of current electricity will obviously happen after 20th of May or 22nd of May, only after your KVPY exam and board exams are over for physics, not before that. Next thing, if you have multiple masses, then find the potential energy for each and every pair. This. So every pair you need to find the potential energy. Keep this in mind. That's one thing. Now, often you will be used or asked to find what is the change in the potential energy, what is the work done, etc. So whenever such things happen, when the configuration changes, so when you basically change the configuration, change in the configuration, then the work done by external agent will be, remember, delta U, the change in the potential energy, meaning final minus initial potential energy. This formula also comes in electrostatics. You will see that charges are there, they are moved around, and then you will see that their final potential minus initial potential energy will be the work done by that external agent to pull them apart or to change the configuration. And remember one more thing, this is negative of the work done by gravitational force. This sign is very important. External force, if it does positive work, Gravity will oppose it. It will do exactly same work but of negative amount. Keep this equation in mind. This will also work for electrostatics. Instead of gravity, you put electrostatic work. Negative electrostatic work is external work, which is also change in potential energy of that electric system. This will work even for magnetism. It will also work for gravitation. Is that clear? Very important equation. Next is potential. Potential energy is U. Potential is having the symbol V. The only difference is potential energy is measured in joules. It's the actual energy present, but potential is the potential energy per unit mass. Think of it as a specific quantity per unit mass. When you do work to bring a mass from infinity to some point, the work which is done per unit mass is called as the potential. So if you remember the definitions correctly, you will also realize that gravitational potential energy is also defined as the work done to bring a mass from infinity to that separation, whatever is there right now. So that is the potential energy. But potential is defined as the work done to bring a test mass from infinity to that point per unit test mass. So it's divided by that test mass. That's how it is. So keep this in mind. There is a small difference. And you will notice that even in the units, the unit of potential is no longer joules. It is joules per kg. Whereas energy was just joules, this is joules per kg. Keep this in mind. So it's per unit. In electrostatics, same definition is there. Instead of the word mass, you will see charge. Work done to bring a test charge from infinity to that point. Hence it will become joules per coulomb, which is called as volts. 1 volt is joule, 1 joule per 1 coulomb. That's the only difference. And you will see that the formula which works for potential due to a point mass is just given by G negative, do not forget Gm by just R. Very important formula again. Just Gm by R. When you put R square and there is no minus sign, it becomes field. When you remove an R, it becomes potential. That's it. Yes, Shweta, it does. Very good. So formula for potential. Same thing will be there for electrostatics. Instead of G, you will have K. It will be K Q by R. No minus sign, of course. Okay. Now, this is the most important formula. Keep this in mind. There are more formulas for spheres, rings. I don't want to discuss that because you will learn that in electrostatics. For now, just remember the shell formula. Thalapati Vijay, just imagine Thala. If you want to become Thala, you have to remember all these things. You have to understand it slowly. It does not come in one day. Number one. Number two, imagine if you do not study this, how much difficult it will be to study electrostatics. Okay? Because the same thing is there repeated exactly. Instead of mass, it's charge. Instead of G, it's coulombs constant. So it's very important that you relate everything. It's very much similar. So see, I'll tell you in general, just going back over here, there are 4 things which are there in this entire chapter. If you notice, if you want, I'll just bring it on other slide. Just 1 second. There are 4 things mainly in this chapter. So what you have is basically force, which is F. Then you have field, which is E. Then you have potential energy. Okay, potential energy, which is U. And then you have just potential, which is V. Remember the basic formulas. You will automatically remember the definitions or any other thing. For example, for force, the formula between two masses is Gm1 or G capital M small m by r square. For field, it is Gm by r square. Unit of force is Newton. Unit of field is Newton per kg. Correct? This is how it is. This is Newton per kg per unit mass. Now if you go for potential energy, you will realize here the formula is nothing but minus Gmm by r and the unit is joules. Whereas for potential, the formula is just minus Gm by r, unit is joules per kg. Potential and field are related exactly similar ways to force and potential energy, if you notice. Now does it make a little bit of sense? Force is to field, potential energy is to potential. Divided by kg, you get field and potential. Very, very easy. Remember this diagram. It will help you a lot. Clear, Thalapathy Vijay and others, of course. I hope this makes sense. This chart makes sense. It's a more specific term. Remember, joules per kg, Newton per kg. All right. So moving on ahead. Okay. All right. So what do we have? Yep. So for a shell. Now again, just like before, you have two things over here when you are inside and outside. So first, when you are inside, r is less than r, and basically you are inside. And the second thing is basically you are outside. So r is more than r, so you are outside. When you are outside, the formula is simple. The formula for potential is just minus Gm by r. It's as if a point mass at the center. Look at this. If the entire mass of the shell was at the center, the potential at this point will be minus Gm by this distance. It's exactly the same formula. No difference at all. But the catch is when you are inside, be careful about it. How many of you know the formula? Let's see. How many of you know the formula? This is the radius of the shell. This is the mass of the shell. When you are inside, then there is a small change. Keep this in mind. It's not zero. Field is zero. Potential is not. In fact, it is minus Gm by r. It means it's constant. It's constant everywhere. It's same. It's equipotential. This point. Everywhere the potential is same. Hence, the field is zero. In fact, you will see this later on that if you have a field, it always goes from high potential. It goes from higher potential. The force per unit mass always goes from higher potential to lower potential. But if the potential is same everywhere, field will be zero. Or conversely, if field is zero, there is no field at all. That means the field is not traveling because everywhere the potential is same. So the complete shell has the same potential as minus Gm by r. R is the radius of the shell. Keep that in mind. Capital R. It's not small r. Have you understood this? The same formula is there for a shell which is charged as well. Let's solve some questions, guys, coming up on your screen now. The gravitational potential energy of a body of mass m at a distance r from the center of the earth is u. What is the weight of the body at this distance? Come on, very easy peasy lemon squeezy question. Is it u by r, ur, minus u by r, or minus ur? Let's see how many of you can give this very quickly. Come on, my warriors. Last few questions before we end the class. What is it? U by r, ur, minus ur, or minus u by r? Come on, Anmol saying C. Potential energy of a body of mass m at distance r from the center of the earth is u. So u will be minus Gmm by r. This is the formula for a solid sphere's potential energy when you are outside. Correct? This is the formula. Now, the weight of a body is nothing but m into g, and g is, g is nothing but g m by r square. So try to get it in that form. You will realize what it should be. You will notice there is g m by r over here. There is 1 by r over here separately. Write this r separately. Now g m by r is this one, if you notice. So g m by r technically is minus u. So just replace this with minus u divided by r. That's all I have done. So just take this and substitute. So it will be minus u by r, which is option C, of course. Yes, draw and Anmol. That's the correct answer. So you should know the formula for potential energy, and weight is mg. That's it. Substitute this over here. That minus sign is important. Many people skip that minus sign, and you will see that many students get the answer as option A. So that's a wrong thing. So be careful of that minus sign. That minus sign is only there in gravity. It's not there in electrostatics. Keep this in mind. All right, moving on to the next question. Thank you so much, Sushma Danis, and I hope that you have already hit the subscribe and smash the like button down there. Potential energy of a 4-particle system, each of mass 1 kg, which are placed on the 4 vertices of a square of length 1 meter. Very standard, very important question. They can ask a lot of questions derived on this formula, like what is the work done to expand it, what is the change in the energy. So many questions come directly on this concept. Sometimes they give you a triangle, sometimes they give you maybe even hexagon, who knows. So first of all, start with drawing those 4 masses. Right over here, they are on the sides of a square whose side length is 1 meter and mass is 1 kg each. So 1 kg, 1 kg, 1 kg, 1 kg. Now if you notice, you have to measure the potential energy for each and every pair. All the pairs have to be added. So let's try this out. So the total potential energy, how many terms will be there? NC2, 4 points. How many lines can you draw? 4C2. So 1, 2, 3, 4, 5, 6. 4 sides and 2 diagonals. So what are the 4 sides? Oh, all the terms are similar. So it's going to be simple. Minus g into 1 divided by distance is 1 square. But that will come 4 times for all the sides. But for the diagonals, oh, this is 1, this is 1. Obviously, this is root 2 meters. Correct? 1 square plus 1 square is 2. Root of that, that's the hypotenuse using Pythagoras. Plus, there are 2 diagonals. I'll take care of that later on. But any 2 masses will have a potential energy of minus g m by distance, which is root 2. Okay. Oh, sorry guys, I just did a square over here. My bad. I'm so sorry. This was not force. This was energy. No, there is no square. I'm so sorry. Okay, so just root 2 over there and into 2, because these are diagonals. That's it. So minus g is common, and what is there inside is 4 plus 2 by root 2. So this will be minus g. 4 plus 2 by root 2 is 4 plus root 2, which is minus g. I think decimal answers are there. So root 2's value is 1.414 in third decimal. So it will be minus g. 4 plus 1.414 is nothing but 5.414. Is that option there somewhere? Oh yes, almost 5.4 with negative symbol. So minus g into 5.4. That's it. Got it? So whenever you have multiple masses, multiple charges, the concept is same. Take all the pairs. And remember one thing, especially if you are in JEE, you will know that the number of terms over here will be equal to NC2, which is n into n minus 1 by 2. So here n was 4, 1, 2, 3, 4. So you will have 6 terms. 4 plus 2 is 6. 6 terms over here. That's how it always works. Is that okay? So that's one way you can verify. Have you written down all the terms, or have you missed out any one term while writing the equation? What is the next question? the change in the potential energy when a body is moved from the surface to a height of n times the r from the Earth's surface is? Let's have a look at this question. Beautiful question. I think a lot of manipulations will be there in this as well. So this is the planet Earth. This is the radius r. You are taking this mass. Earth's mass is capital M, and you are moving this up by a height of n times of r over here. So this is the new height. So the question is, what is the change in the potential energy? Did I not tell you there will be questions on change in the potential energy as well? Many times you will see that, not just in gravity but also in electrostatics. Let's try and solve this question. Okay, so change in the potential energy means delta U, which is final minus initial. Final means when you are here. When you are here, this entire object behaves like a point mass. Entire object behaves like a point mass. So it will be minus G, mass of the Earth, into mass of that object divided by the entire distance. Be careful, this is the entire distance, which is nr plus r, which is r common into n plus 1. Total distance from the center, that will be r into n plus 1. Minus, this is the first term, minus. When you are on the surface, that's the initial energy. So it will be minus gmm. The distance will be just the radius of the Earth. That's it. Many things are common. Bring it out. Simplify. So G is common. Capital M and small m. Even the R is common. So this will become minus 1 by n plus 1 plus, because minus minus is plus, 1 by 1. So I think we should take the LCM, gmm by R. And yeah, just take the LCM. It is 1 minus 1 by 1 plus n. So it will be nothing but, just look at this, 1 by n plus 1. So this will be nothing but n plus 1 minus 1 by n plus 1. So 1 gets cancelled. So it will be nothing but gmm, 1 of the n will remain, upon r into n plus 1. That should be the answer, guys. Is it there somewhere? No, it's not option A, it's option C. This one, the n is also there on the top. N is also there on the top. Be careful, guys. Okay, is that clear? Everybody understood? Okay, how will I do this in the exam? I'll tell you. How will I do this in the exam? Will I actually end up doing all of this? I doubt. You know what I will do? What if n was 0? What if n was 0? If n was 0, that means, if n was 0, that means, you know, you are at the same point. You are at the same point. Correct? So the change should be 0. So if I put n is equal to 0, I should get 0 as the answer. So in this, there is no such, oh, there is an option which has matched, bacha. This is option C. Golu, option C matched, by the way. Oh, so here there is no n, so option B got eliminated as it is. So you can eliminate certain options if you have very little time, for example, in the exam, and you don't know how to solve, and you want to maybe mark the answer by fluke, or you just want to guess, at least eliminate few options. Similarly, yes, correct, very good, Gokulnath, you have to eliminate it. And also, if I put n is equal to 1, just imagine n is 1, that means you are at some height. You are at some height. From here to here, obviously potential energy will change, and it will not be infinity, na? If n is 1, example, from here to here, some potential energy will change from r to 2r. Now if you see option A, if n is 1, this answer becomes infinity. So hence even this can't be correct. Even this can't be correct. Hence these two options are gone. It will be for sure one of this. For sure one of this. That's how you can narrow down on options. And this is what I mean by elimination, substitution, manipulation. This is what you need to do and learn. Moving on, next question. A particle of mass m is situated at the center of a spherical shell of same mass and radius is a. What is the potential at a point at a distance a by 2 from the center? I feel that we should draw the diagram. Without that, we will not get it. So let's draw a shell. This is a shell of certain mass, let's say capital M, and radius is a. Alright, so the radius of the shell is basically A. Now what you have done is you have put another mass, a particle of mass m is situated at the center. This is another mass, same value at the center, and you have to find the potential at a point at a distance of a by 2. So you have to find at this point, there is nothing here, at this point which is at a distance of a by 2, what is the potential? Let's see how to do it. So the potential at point P is because of two things. This mass will also create potential, the shell will also create potential. So it's because of the potential of the particle and also because of the shell which you are inside of. You are inside the shell, remember. Now just use formulas. When you are solving for this, forget that the shell is there. When you are solving for this, forget that the particle is there. Independently add their potentials. Potential is scalar, so you can add them, no need of directions. For the particle, don't look at the shell. Just look point mass and you are here. What is the formula? Point mass, gm by r, negative sign. So just put minus gm by the distance, which is just a by 2. That's all. This is for a point mass. Next, when you are inside a shell, if you remember correctly, I have already given the formula. When you are inside, it is constant for a shell. It is minus gm by the radius of the shell. So it's not 0, guys. Some of you thought that it will be 0, maybe, but it is not 0. It will be minus gm by the radius, which is a. Now simplify this further. So minus gm by a is common. From here 2 goes on the top. A minus has been already taken out. So it will be just 1 which is common. So it will be minus 2 plus 1 is 3. So minus 3 gm by a. Is it there? Yes, option A. Who was it? Very good, Hari Prasad. Excellent. That's the answer. Now you know that if this problem was replaced by charges, there is a charge shell, there is a point charge inside. What is the potential due to these charges? Same method. Instead of G, you will have Coulomb's constant. Instead of mass, you will have charge. No difference at all. Okay. Last question. Draw the graphs of potential versus distance for a shell and a point charge. Very simple. Let's start with point charges first. So for a point, oh sorry, this is not charge, this was supposed to be mass, guys. I'm so sorry, but anyways, it's the same thing. It's the same thing. So you have a point mass and you are at a distance r. The formula for potential is minus gm by r, right? So how will the graph look like? This is the potential, this is the distance. First of all, realize the graph will be below this line because of the negative symbol. It will be negative symbol, so it will be below. So it will look like this because it is inversely proportional to r. So if this minus sign was not there, then the graph would have been in the first quadrant if the plus sign was there. But because it is minus, it will be exactly replica, mirror image below. So this will be the graph. You will see as r becomes very large, the ratio becomes very small, close enough to 0. That's how it is. Now for the shell, so for the shell, if you remember correctly of radius r, when you are outside, then it is minus gm by small r, but when you are inside, it is minus gm by capital R, which is constant. Here it is inversely proportional to r. Now just make use of this fact and start drawing the graph. This is potential, this is distance, this is 0. First of all, when you are inside, that means still the distance reaches the radius. It is constant and negative constant. So just draw a horizontal line and this will be minus gm by the radius. As soon as you cross the radius and come outside, it is inversely proportional but from the negative side, so it will look like this. That's all, and this happens only till r. This is inside, that is outside. Is that understood, guys? So these graphs should be understood. Remember, for charges, this graph will just shift on the top if it is a positive charge. That's all. Okay, simple. Analyzing the graphs, it's simple. Yes. Hello, Bigi Show. Oh, I have a homework question for you. Two bodies are there at some distance, and the potential at a point has to be found where the field is 0. So two masses are there, somewhere in between their fields will cancel. At that point, what is the potential? Yes, it will not be 0, I'll tell you that. Okay, solve this, drop the answer in the comment section, and I will be putting it up, the solution, in the PDF form, in our channel. In our channel, you will be getting the entire PDF with the solutions, guys. And those of you who want to study with me, Shimon sir and Harsh sir, and that too in English medium, we have a batch exclusively for all of you, especially for all the 11th to 12th moving students. There's a batch which has just started, there's a batch which is just starting, and the best part about the batch is the classes are regularly placed. It's not like just recordings given to you. The class recording is available even after the class is over till the next year. In the class, you have second teacher who will solve the doubt. I might not be able to interact, but that's okay. You have the second teacher in the class. You can give feedback, you get feedback, how you are performing, and this feedback is different for every person. If you don't do well, you will get to know. Okay? And sometimes you don't know whether you are doing well or not. And in the class interaction, like the chat box are open, hotspots are there, leaderboards, your ranks are being given, how you are performing, everything, all these interactions with class teacher, notes, PDF is available. So after the class also you can see what are the handwritten notes, assignments after every class, fortnightly tests, that means tests are being conducted regularly after the entire syllabus. Mock tests with revision is also there. Yes, the 11th standard portion will also be revised. Not just that, test series is also included. Also the booklet is given to you. The books are given to you. Hello Malvika. Okay, so keep all these things in mind, because the course price is hardly 7,999 when you use my coupon code. If you are watching this video right now, then you will notice that in the description box, below, you will notice there are many links. This is the JEE course, this is a NEET course. So you can choose whichever course you want to join. If you are aiming to be a doctor or go into medicine field, you can see the course starts on 23rd May, but don't delay it, because the batches, okay, will get filled fast. Number one. Number two, you will still have access to the content even now. So don't worry about it. All the important recordings, all the important other notes, everything will be available so that you can start your journey. Don't wait. Okay. And you get VIP, meaning that if you do not improve, all your money is returned back. Hardly we are taking some 8,000 rupees, and that money also will be returned back if you don't perform, but I'm pretty sure you will do well. Same thing is also there for JEE. You can see right over here, and all the best teachers out here for you in English medium. 1 year course plan. Now, I'm so glad, Vasundhara, you are new to Vedantu, and I'm pretty sure you will start the journey with all of us in this special batch. This batch with the YouTube classes will be the best sure shot combination for you guys to get into the best colleges, be it IIT or be it AIMS. If your aim, your ambition is one of these two, then please consider joining the batch and watch my YouTube classes with the regular batches. And Chaitra, so yes, please let me know which grade are you in and what kind of issue you need help with. Like, where do you wanted the important chapters, I believe, but depending on which grade I can help you out. Okay, Monisha, I have heard that request. I will try my best, bacha, but I can't guarantee. But I'll tell you something. Whichever teacher is there now, he will be for sure better than me only. Don't worry about it. There will be awesome teachers. If you face any difficulty, you come and tell me. I will only come and teach you. But I'm 100% sure they will be awesome. So if you are a dropper and you studied nothing in physics, you didn't attend single question from physics. I only studied for my board and 11th and 12th, that too 1 year ago. So you want to get into medical seat. So Chaitra, that's a grave, serious issue considering that you are a dropper. So number one, watch Zero to Hero playlist. Number one. Where is it? Here. I'll just go back maybe. I'll tell you what and all you should do. You should do this. Don't tell me after 1 month, sir, I did not do. I don't like physics. No, you have to take these pills. There is no cure for this otherwise. Okay, just like if you become a doctor, you will also suggest some medicine. I am suggesting you the medicine. Okay, zero to hero physics. So this is superhero, my bad. Zero to hero is somewhere here. Where did it go? It's here. Oh, yeah. So last minute revision, just go down here. Zero to hero physics playlist. This is the number one thing that you should watch. When you watch this, you will realize what mistakes you are making, which concepts are weak, etc. Along with these classes, simultaneously watch the crash course NEET classes, NEET crash course classes, one-shot classes of physics. Even other classes are there. Wherever you feel weak, wherever you feel that you need help, watch those classes. But do this and that together, number one. Now, wherever you feel that you need extra help, go down, watch those specific classes from 12th standard. See, you can see physics, or from 11th standard. This is 11th standard. Watch that. Got it? And what you do is, once you have watched the specific classes of 11th or 12th, and now your concepts are clear, you're solving the same problems which I'm doing in these classes, crash course, then pick up the assignment. Assignment, you will get it in the crash course as well. If you have already assignments from some other institute, good. But if you don't have, if you want to follow one specific standard systematic way, go with the crash course. Solve all those problems. That will keep you busy. Then after that, start giving part test at least after 60% portion is over. And then you give full syllabus test. Keep a target. Now it's May beginning. By June mid, you should complete it. Yes, and I'll tell you something, it is possible. And don't do all the chapters. Just do the major important chapters like current electricity, electromagnetism, correct? Modern physics, important. Then waves, okay, all kinds of waves. Then mechanics, rotation, SHM, Newton's laws and work per energy, circular motion, all of that, gravitation, all of that, do that. And then when you have time, then you can do thermo, and then maybe you can do some other chapters like solids and other stuff. So do this, trust me, by June mid, you will be fully sorted. Even if you don't complete entire syllabus, it's okay. You will at least complete 70 to 80% of the portion. First, which topics to do? Do mechanics first, then go to electromagnetism, then go to optics. Note down the order: mechanics, electromagnetism, then optics, and then go to other stuff. It could be anything, then the order does not matter. But do the high weightage chapters like modern physics first, then waves, all these things, light waves, sound waves, transverse waves, everything, electromagnetic waves, all these things will come. Okay. So my state board 11 did not complete it. When will the new batch start of AI, sir? In June. And when? Oh, JEE 2023, the new batch will start. You can see it right over here. JEE Mains plus Advanced, 9th May. That's 2 days from now. This Monday it will start. Even if your board exam is not over, I would suggest join it now only. Don't wait for June batch. It will be too late, bacha. Think na, it will get over very late. You will get less time for revision. Start now. Don't wait for June. Very bad decision. June is latecomer. You know that. People have already started and completed 1.5 months. Our first batch started in 28th of March almost. Many people are already 1.5 ahead. Yes, this lecture is for Kishore Bacha. I don't know whether you see my videos. Do you see the title, Bacha? See, na? JEE NEET 2023, studying all the students who are going to come to 12th standard, JEE and NEET both. Okay, so don't wait, my students. Don't postpone, don't say tomorrow. Please do things today and watch my lectures along with the pro subscription. I am assuring you, you will become a doctor from a good college with government seat. You will become an engineer or a researcher or a scientist. You will fulfill your dreams from the best IITs, best NITs, best colleges in India. There is nothing more needed. Thank you, Monisha, so much. Jesus, is physics scary or tough? I'll be able to, yes. Physics is physics scary and tough? It depends, Jesus, Sheila. I mean, like, if you are not studying it properly, it is scary. If you're like, I remember for me, chemistry was scary because I was not being taught properly. Okay, some chapters in physics were also scary for me when I was preparing because I didn't pay attention. I won't blame my teachers. I had backlogs. I remember by the time light waves and all these things came, I had so many backlogs. I didn't pay attention to what is going on in the class. So I developed backlogs and I lost interest in those topics. So clear your backlogs, solve it properly, make notes, solve examples, go through simple problems, then do PYQs. You will be sorted, bacha. I'm pretty sure, Chaitra, you will crack it, and I will be eagerly waiting to meet all of you. Sir, the Vedantu app will work, Shweta. There were some issues in between because the app was getting updated. Thalapati, I have made a video on aeronautical engineering. So please search Shreyas sir aeronautical engineering or aerospace engineering. You will get the answer. It's there on YouTube, on this channel only. Okay, Thalapati, that's it from my side. I hope I have answered and cleared all your doubts and queries. Be regular, stay smart, stay updated, and keep working hard. Shreyas sir, your captain, is always there to lead you. Remember that. Bye bye. Hasta la vista. Signing off.